Alright, in this video we're going to do a bit of geometry to determine the area of a parallelogram. Let's start by taking two vectors. So let's call them A, which has components A1 and A2, and B with components B1 and B2. And then our goal is to determine the area of the parallelogram, which is spanned by the vectors A and B. And that means that we're looking at the parallelogram with corners the origin, the tip of the vector A, the tip of the vector B, and the tip of the vector A plus B. And our goal is to determine this area A. Now, as a first step, I'll introduce just a little bit of extra notation. So the angle between the vector A and the x-axis we'll call alpha, and the angle between the vector B and the x-axis we'll call beta. Now, with that notation, we see that the area is equal to the length of the vector A times the length of the vector B multiplied by sine of beta minus alpha. So what we're using here is that this parallelogram has base length of A, it's just the length of this vector here, and then the height is given by the length of B times the difference between the angles. So basically what I'm doing is taking this parallelogram and rotating it so that A coincides with the x-axis so we can use it as a base. And after that rotation, the height of the parallelogram is given by the length of B times the sine of beta minus alpha. So if I have any vector v, then I can consider its x component and its y component, and I can look at the angle with the x-axis. And then the x component is given by the length of v times cosine theta, and the y component is given by the length of v times sine theta. So this is a useful thing to know about vectors in general. And now we apply these formulas to our specific situation. And as a result, we get the following formulas. A1 will be equal to the length of A times cosine alpha. A2 is equal to the length of A times sine alpha. B1 is equal to the length of B times cosine beta. And B2 is equal to the length of B times sine beta. Now we take these formulas and plug them into the expression for the area that we had before. So we can't apply these formulas directly. First, we'll have to rewrite this sign. So this is equal to the length of A times the length of B times cos alpha sine beta minus sine alpha cos beta. So we simply expand the brackets here and reorder. And now we can finally use our formulas. So what we actually calculated here is the signed area and not the area. And that's because this sine of beta minus alpha can be negative or positive. If I actually wanted the area, then I should have taken the absolute value.